Hello and welcome to my third video in my How to Arduino series. This video is going to be covering buttons, what they are, how to use them. That's really all you can do with buttons. However, it's a very important thing. If you have something where you want to tell an Arduino what to do and you don't want to hook it up to a fancy computer system, a button is probably one of your best bets. And buttons are used everywhere. It's one of those things where you don't realize how many buttons there are. There are buttons in your keyboard, there are buttons in your car, your phone has buttons on it, like buttons are just everywhere. They're so ubiquitous in life that it's actually kind of hard to find stock footage of them because they're just everywhere and nobody cares. At least I only looked at one side, but here they are. So let's get started with this by first going over our list of topics for this video. First, we're going to go over buttons and floating pins. Then we're going to do an example of how to hook up buttons. Then we're going to do an example of how to do multiple buttons. With that said, why don't we just jump right into it? Buttons. They are actually known as momentary contact switches. That's because as you push it down, it makes contact. When you let go, it stops making contact. Therefore, the contact is momentary, as can be seen here by the schematic of it. You push it down, it makes contact, let go, open circuit. Easy peasy, lemon squeezy, right? Now, the ones that you have in your kit, you might notice, have 4 pins. Here's the underside one where you can see all 4 decently. Kind of blurry, but it's hard to take pictures of this. The way these work is that 2 of them are tied together on either side, and then there's the opening in the middle. There's 2 ways to find out which ones are tied together. So if you look at it from the side, you see that these ones have a little hook in the legs. The ones where the hooks face each other are tied together as a single piece. So this one here is just a metal piece that runs up, around, through here, and then out. The other way to tell what it is there's lines on the bottoms of these that demonstrate which ones are connected. So this is a hooked one and that is a hooked one. You can see a bar across that's showing that they are connected. When you are connecting the button into your circuit, you have to make sure that you are connecting across the spots. You do not want to connect the 2 that are hooked together. That's kind of pointless. It's just a wire. So in this case, you'd have to hook from this side to this side or from this side to this side. It's just turned 90 degrees so you can see what was going on. And that leads us into how do you hook things up onto an Arduino? This is probably the most obvious way to hook up a button. You would connect one side to one of your digital pins and the other side to either ground or the 5 or 3.3 volts. There is, however, a very severe problem in this setup, and that is shown on this slide. So this is the same as that circuit. You have this side tied to the number 12 pin, as it was before, goes through a switch, some other stuff just to show that there's things there, and then to the ground. So, what is wrong with this setup? It seems like it's completely obvious that this is how it works. When you close the button, it closes the path and it works just fine, right? No problems. The problem comes in when the button is not pushed. When the button is not pushed, the circuit looks like this. It's just an open circuit. So what is wrong with having an open circuit here? Obviously there's no power flowing, so there shouldn't be a problem. The problem comes up when the Arduino's microprocessor tries to listen to find out whether or not this is a 1 or a 0. When it's not hooked up like this, it is what is called a floating pin. It literally could be a 1 or a 0 completely at random. It changes constantly. There's no real rhyme or reason. There's a million things that can make it change, and that's bad. We want this thing to be very secure in whether or not it is pushed or not. We don't want it to be definitely pushed when it's pushed and sometimes pushed when it's not pushed. That defeats the purpose of having a button, correct? Think about if it was supposed to launch a missile. Like, it doesn't ever launch a missile unless you push the button or it feels like it, right? That's bad. It's not what we want. So the way that we hook it up instead is like this. It's the same exact thing. We tie pin 12 to the button and we tie the other side to ground. However, we take the 3.3 or the 5 volts, it really doesn't matter, and we tie that through a resistor to pin 12. So when the button is not pushed, the current goes through the resistor and into pin 12. So it is definitely a 1 because it is receiving a voltage. That makes it 1. when you push the button, everything syncs to ground and nothing goes to pin 12. So when that happens, it's definitely a 0, and then we are sure of what is happening. So what I want you to do is I want you to wire up this circuit. Then we're going to jump over and program something to show how this works and make the button work. So here we are back in the Arduino editor. You'll notice this time I've started with the program a little more done than it's been before. My plan is I'm going to eventually cut out smaller and smaller parts so you don't have to watch me do the same redundant things over and over again, which in itself is redundant. So as we've done every time, first we're going to declare our pins as variables. We'll use a constant integer like we did last time, and we'll need one for the LED, which is built into the board. No need to put another one on for this. And then we'll need another one for the button, which I will call but, because it's short for button. Yeah, that's why. It's not because I'm childish at all. So there's our variables for that. If we had any variables that would change, I'd put them in this section, but we don't. Right now we only have constants. And now we need to do our pin modes as always. First we'll do the LED, which is an output, we know that. So now, when we put in the one for our button, we need to make it an input because we're going to input information into the Arduino. Easy peasy, right? No problem. Our plan is that we want it so that when the button is pressed, the light turns on. So what we will do is we'll do a simple if-then statement. So we'll do if digital read, that's how you read from the button. You say the pin number, and then you close the if. So if digital read, and then we'll try putting in digital write, LED, high. So if the button is pushed, turn on the LED. Else, digital write LED low. So if the button is pushed, turn on the LED. If not, turn off the LED. Okay, so we will save our new file. Go into here, and we're going to go call it a tutorial because I am a professional. So we're going to call it a butt tutorial. I may or may not have already saved that once. And now we will upload it to our Arduino and see what it does. So we compile a sketch, we upload, and now you see that the light is on until I push the button. That's kind of the opposite of what we wanted. That's strange. So what's going on? Well, you have to think about what's happening. We have the button tied to ground. So when we push the button, that brings everything to a 0 potential, which is then a low output. So what is happening is when we push the button, we are pushing digital read low. However, when we don't push the button, we are having it at a high state. So that means that the button is actually the opposite of what we would initially think. So we can go through and we could change this to low and change this to high. But instead, I'm going to use this as an opportunity to teach you about the bang character, which is an exclamation point. I don't know why they call it a bang, but they do. What that does is it means not. So what we're saying here is if not digital read but. This is exactly the same as saying digital read but equals false. But it is fewer keystrokes and a very valid way to do it if I can type properly. So we will put that in there just to teach you how to use it. I don't like using it personally. I think it's an easy thing to miss when just like glancing over code. I think it's easier to read is equal to false. But I want to teach you how to do it in case you choose to do it and save yourself some keystrokes. So we will save and upload it one more time. And now you notice that when I push the button, the light turns on. It works exactly as intended. And here's the next circuit that I want us to hook up. It looks familiar, doesn't it? It is exactly the same circuit that I had earlier that I said will not work. However, there was something I didn't tell you because I'd like to hold out on you. There is a way to make this circuit work. It is built into the Arduino knowing that this is a problem. And so now I want you to hook up this circuit and I will show you how to do the pull-up resistor programmatically instead of through discrete components. As you can see, we're in the same program that we were in last time that had the working button. But this time we're going to do it without the pull-up resistor. A pull-up resistor is a resistor that pulls up the voltage when it's in its normal state. It's the resistor that makes it so you don't have a floating pin, because as we said before, floating pins are bad. But the circuit I just showed you has a floating pin. What do we do? Well, so it turns out that the people who made the Arduino are kind of smart. They know that floating pins are bad, and they know that the easiest way and the most common way to deal with them is a pull-up resistor. So what they did is when they built the Arduino, they built in pull-up resistors. So if you want to use the built-in pull-up resistor, what you have to do is when you declare the pin mode, which we did here for our input, you would put pin mode, but input, pull-up. And so what it does then is it connects an internal pull-up resistor, and you don't have to deal with having it on your board. So we will upload the program, and as you can see, the functionality is still the same, even though I don't have to have that resistor in the way anymore. This is a handy trick to remember, and don't forget to implement it in your future projects. And for our last circuit today, we have one with 2 buttons. We're going to hook them up the same as we did before. We're just going to add a second one, and that one will be to digital pin 8 and ground. The plan for this last circuit is that we are going to have it so when you push one button, the light turns on, and when you push the other button, the light turns off. And I think a good way to do that would be to use a state machine again, like we did last time. I feel the state machines are important, and a little more practice with them never hurts. So let's start. Once again, we'll start with our constants. So we're going to have bud is going to be pin 12. Button 2 will be pin 8 this time. And then constant and LED will be 13. We'll use the built-in LED just because it's there and it's a little bit easier. Next, we need to set up our pins. So we have pin mode, but input, pull up. Do not forget the pull up. That's a very important part. But 2, input, pull up. And pin mode, LED, output. The way I'm imagining this is that there's going to be 2 states. There's going to be a state for when the light is on and a state for when the light is off. And those states are going to listen for their respective button push. So in order to do that, I'm going to have a changing variable. We'll use a Boolean because there's only 2 states. And we'll call that state. And we're going to set it equal to 0. Normally I call Booleans true or false, but this time I want to have it be in state 0 or 1. So a Boolean has 2 states, either true or false, but the way that those are actually represented are as a 0 and 1. It's a single bit value. So I think in this case we'll use 0 and 1 just so we can kind of understand and play around with that a little bit and mix things up. So now we have a Boolean for our state. So the first thing we're going to need to do is check to see if the first button is pushed. So we'll do that inside an if statement. So we'll do digital read, and then instead of using the bang character like I did last time, I'm going to use the is equal to false technique, just because I feel like it's a little bit easier to read, and I prefer that one. So we're going to look, if the first button is pushed, then we want to turn on the light. So we'll use that as state 1. So state equals 1. Then we need to determine whether or not we need an else. Well, if the button's not pushed, it just won't do anything. So there's no point for an else in this case, so we're just not going to put it. Then we need to check if the second button is being pushed. And we will check to see if that's false, because if the button's pushed, it will pull it to ground. And if that happens, we need to turn off the light. When we turn off the light, we will set it to state 0. Okay? So the beginning of our loop first determines whether or not the light should be on or off. Good deal. Then our loop needs to actually tell the light whether to turn on or off. So we do digital write. It's going to go to the LED pin, and then we're going to send it state. So you see, once again, I've done something entirely different than I've done before, just to show you another way that this can be done. You don't only need to pass high or low to digital write. Digital write needs a single bit value. Now, in order for it to be a little more flowing, people to understand, they've mapped it so that if you write high or low, it changes it to 0 or 1 or true or false. Those are all exactly the same thing. So in this case, we're just going to take the value that we set and we're going to then pass it into digital write. And then that will cause it to do what we are expecting it to do. At least I hope. So we will verify the code and then we will compile the sketch and then it uploads. You can now see that when I push the first button, the light turns on. When I push the second button, the light turns off. Now we have gotten to the exercise portion of the video. I want to combine things from the last RGB light video and this video. So what I want is a breadboard that has an RGB light on it and then 3 buttons. Each button will be a different color of the light. So if you want, you can do red, green, blue as the simple one, or you can combine them, but I want to see 3 distinct colors. So when you push one button, it turns to red, for example. When you push another button, it always turns to green. Another one, you always turns to blues. I will give you a hint on this. I think a state machine will be very helpful. If you haven't noticed, they're used quite a bit already. So if you can build a state machine that will control that, I think that this should go pretty easily. Thank you for watching and following along with these videos. I appreciate your viewership. If you have any questions, please feel free to contact me. I can do whatever possible to help you try to figure out what's going on. And if you have any comments, please let me know as I'm trying to improve these videos. This is the 3rd video in my How to Arduino series. If you missed the first 2 videos, there is a link to the playlist in the description, as well as in the corner underneath the little eye thing. And for the next video, we're going to start covering the serial monitor and sensors. So thank you very much, and I will see you next time.